My name is Tanzim Mustafa, and the topic I'm going to present today is model inversion attacks. So, in this presentation, I'm basically going to give an overview of model inversion attack and some of the concepts related to it. So, let's start with the simple definition of model inversion attacks. Model inversion attacks are a machine learning security threat that involves using the output of a model to infer some of the parameters or the architecture of the model. So one might have a question, what do you mean by output? So output is basically, for example, if you teach a machine learning model to recognize pictures of a cat, the output might be whether the picture has the cat or not. So the model inversion attack uses this output to conclude or find out some of the parameters of the model. So before I delve into model inversion attacks, I would like to explain a bit about why understanding such attacks are important in the first place. So to this end, I'm going to introduce some key terms and shed light on the current landscape of cybersecurity. So first of all, the terms data privacy and data security are important terms that we need to know about. So data privacy is about controlling who can access our personal information, whereas data security involves the protection of the confidentiality, integrity, and availability of our data. So nowadays, organizations face a great challenge to implement proper security measures uh, so that uh, and they find it difficult to comply with data protection regulations to safeguard our personal information. So next point is the rise of AI privacy breach. So recently, model adversarial attacks and AI privacy breaches have become a concerning issue in the field of artificial intelligence. So what do you mean by model adversarial attacks? It refers to the deliberate attempts to manipulate AI systems by introducing carefully crafted inputs that can deceive the model into making some incorrect predictions. These attacks exploit vulnerabilities in the model's decision-making process and can have severe consequences in various domains, including cybersecurity. On the other hand, AI privacy breaches involve unauthorized access or misuse of sensitive data stored or processed by the AI systems. AI systems nowadays rely on vast amounts of personal and confidential data. Therefore, such breaches can result in identity theft, privacy violations, or even financial loss. So it is important for us to safeguard uh, against these breaches. And safeguarding AI systems against adversarial attacks and privacy breaches basically require robust security measures, regular vulnerability assessments, and the implementation of privacy enhancing technologies such as data encryption, differential privacy, and secure federated learning. And we'll be looking at some of these terms later on. So moving on, uh, let's get back to model inversion attacks. And basically, in this slide, I'll explain how the model inversion attack works. So in this attack, the attacker first trains a separate machine learning model, which is known as the inversion model, on the output of the target model, which it is trying to get the information out of. So the inversion model's task is to predict the input data, which is the original data set for the target model. And by analyzing the inversion model's predictions, the attacker can learn information about the data subject, which we didn't intend for the target model to reveal. Next, I'm going to provide two examples so that it is easier for us to understand model inversion attacks. So the first example, uh, suppose we train a machine learning model to predict whether a person has a heart disease based on their medical history. In this case, an attacker who doesn't have access to the individual's medical history could use a model inversion attack to gain knowledge about the individual's medical history. The attacker does this by using the machine learning model's output, which are the heart disease parameters or features. He uses these as the input to the inversion model. Then the attacker trains the inversion model to predict the person's medical history, ultimately inferring personal information about the person's health. For the second example, this is from a paper by Fredrickson in 2015, uh, where they were able to basically reconstruct facial images from a machine learning model that was designed to predict demographic data. So this is an illustration that has been taken from the paper. And the left image basically shows is the image that was recovered using the model inversion attack. And the right image is the actual training set image of that person. So, and it also mentions that in this case, the attacker was only given the person's name and access to the model, which gave class confidence scores as outputs. And by using this confidence scores, it was able to basically reconstruct this particular image, which is very close to the original image. Uh, Moving on, now I'm going to talk about black box and white box settings in model inversion attacks. So, in the context of model inversion attacks, the term black box and white box, they basically refer to the level of knowledge an adversary has about the target machine learning model. In a black box setting, the attacker has limited access to the internals of the target model. They can only interact with the model by querying it with input data and observing its outputs. The attacker does not have access to the model's architecture, parameters, or its training data. And black box attack require more queries to the model, and hence they are less effective than white box attacks. However, these represent more realistic scenarios as attackers have typically limited access to the target models in real world settings. On the other hand, in a white box setting, the attacker has full access to the internals of the target model, including its architecture, parameters, and training data. The attacker can basically inspect the model's architecture and directly observe its internal representations. And this makes white box attacks more powerful and efficient compared to black box attacks, since the attacker basically has all the knowledge of the target model. Next, I'm going to explain some of the types of model inversion attacks. So, model inversion attacks come in various forms, and each of them targets different aspects of the machine learning models uh, to try to find and infer some sensitive information from that model. So, first of all, I'm going to explain the query-based attacks. In query-based attacks, adversaries exploit the model's query interface to extract information about the training data. They do this by basically asking the model specific questions and analyzing their responses. So this is an image uh, referring to the query-based attack, where basically the attacker gives some queries and tries to uh, infer uh, the result and the get some information about the model. In the next point is the membership inference attack. In membership inference attacks, adversaries try to figure out if a particular data sample was part of the model's training dataset. So they do this by observing how the model behaves when given different training data. So as you can see, uh, this is the original data used to train the model, and the attacker tries to find the data sample which is a subset to this training data. And this basically lets attackers determine if certain individuals' data was used to train the model, uh, which basically means revealing their sensitive information. Next is the generative model-based attacks. So this was taken from this paper by Huang et al. And in generative model-based attacks, basically they use generative adversarial networks or GANs to trick the target model. So they train the generative model to create data that mimic the target model's outputs. And this basically allows the attackers to uncover sensitive information about the training data and exploit vulnerabilities in the target model's predictions. So understanding all these types of model inversion attacks is crucial for developing defense mechanisms that will be effective and that can basically reduce the risk associated with information leakage, basically leakage of sensitive information from these machine learning models. So to that end, in this next slide, I'm going to explain some of the prevention techniques from model inversion attacks. So first, one of the primary countermeasures against model inversion attack involves basically the encryption of both the model's inputs and their outputs. So an example is an homomorphic encryption, where the data is encrypted in such a way that computations can still be performed on it even when it's encrypted. This means that if the attacker somehow gains access to the encrypted data, they can understand this encrypted data and like figure out any patterns between the original input and the original output. Next is the secure multi-party computation, or SMPC. So SMPC basically adds another layer of complexity for attackers uh, by enabling the collective computation uh, by different entities to maintain data privacy. So in the context of machine learning, SMPC allows different parties to work uh, on their own parts of the data without sharing it directly with each other. So this makes it extremely hard for an attacker to compromise the system because they would have to breach multiple independent systems, which adds a lot of complexity and makes it harder for them to succeed. Uh, Next, another technique uh, for prevention is called the differential privacy. And differential privacy is like adding some noise to the original data to protect the individual's privacy. So, for example, suppose we have some data about a group of individuals, like their age or their spending habits. So, with the differential privacy, before doing any calculation or analysis on this data, we add a small amount of random noise to it. And this basically ensures that even if someone looks at the results of our calculations, they can't figure out the specific details about that individual's data. So with differential privacy, we get useful information from the data while keeping the individual personal information safe. And this diagram basically shows a method of adding random noise using the Laplace mechanism. And basically, yeah, it adds the noise, and in this way, it can uh, achieve differential privacy on the data. Lastly, is federated learning. Federated learning is a way where multiple devices like smartphones or even computers, uh, they basically work together to train a single machine learning model without sharing their private data with a data with a central device or server. So instead of sending all of their data to the central server, each device keeps its data private and only shares the updates or the weights about what it has learned with the central server. The central server then combines all these updates or weights to improve the overall model without having to see the actual raw data from any device. And in this way, federated learning basically ensures privacy of each of the device's data. So to summarize, one of the key takeaways of this presentation is knowing how adversaries can exploit vulnerabilities in machine learning models and get information about the training data. We discussed uh, some of the several prevention techniques in order to defend against such model inversion attacks, such as input and output masking, secure multi-party computation or SMPC, differential privacy, and federated learning. And for future directions, basically, uh, there are a lot of opportunities for further research and innovation in cybersecurity for machine learning, as new threats are constantly emerging, and it is imperative that we explore new techniques or new defense mechanisms, and it is imperative that we stay proactive in addressing such threats. So these are the references I used for this presentation, and that is all. Thank you very much.